This is still section 1.5 that we're talking about right here. And in this section, we also need to talk about a different way of combining functions. And the different way we talk about is when we say composing and decomposing. When we talk about composing a function or getting a composite function, they look like this. And we say f composed with g. What does that mean? Well, it means that you focus on the inside first. If I know what g of x is, I input something for x, I will get a g of x output. That output here goes into the f function and becomes part of it. So this explanation up here where you say take the result of the first function, the inner function, use that to evaluate the second. So the input is the output of the other function. We'll see what this looks like. Another way you can write a composed function is to say f of g of x. So this first one here, here's our f, here's our g. We're asked to find f of g as well as g of f. Now remember, when you see it this way, this is the same as saying f of g of x like this. This one, g is on the outside, f of x. And then we'll evaluate each of these when x is equal to 2. So for our first one here, this is saying that f is my outer function. Okay, so when f is my outer function, I'm going to go ahead and put the f function, but notice I left out the x. It's the same pattern, but I didn't put an x in here because instead of putting in an x, I'm going to put in a function, g of x. So the g of x function comes inside and sits inside of the place of x. Once I have that, I simplify it. And so to simplify this one, we'll have and then to evaluate when x is 2, so f of g of 2, and for this one I'm going to just use the calculator really quick, save space. $104. So that's when it's 2. Here's the composition. To do g of f of x, that's the second one, and that's saying that g is the outer function. So I'm going to put the g pattern, which is 2x plus 6. Again, I just put the pattern, leaving the input space blank for the entire f function. The entire f function is x squared plus 4. Simplify this. And then to evaluate when this is 2. There's the function, there's the value. Okay. Let's do another one. This one here, we're given a different f of x, a different g of x, and we're asked to find just one, just the g of f of x, and then what's the domain of the resulting function. Remember, the g of f of x is the same as saying g is the outer, f is the inner function. So we're going to put the g pattern first. What is the g pattern? That's 2 plus 1. So leave the space. And into that space, we're going to put the f of x function, which is just 1 over x. So this, you could say just 2 times 1 over x, or you could say 2 over x plus 1. That's our composed function. What's the domain? Now, for domain, especially when you're composing functions, you have to be really careful that you check the first thing, the second thing, and then your final result. So for this one here, what can x not be? Well, it can't be 0. X cannot be 0. This one here, no problem. X can be anything. check the result and look through it here. It's the same thing, 1 over x, you have a 2 over x, x still can't be 0. So we'll say that our domain goes from negative infinity to 0, skips the 0 value, and continues on to positive infinity. This one beneath it here is actually the same two functions, but now we're going to do the reverse. We're going to say what's f of g. So again, that's f on the outside, g on the inside. So the f pattern is 1 over something. Into that something, let's put the g, which is 2x plus 1. And that's it. There's nothing to simplify. It just is a fraction. Now when we look at the domain, again, from the f of x function, x cannot be 0. No problems with 2x plus 1. But now the result is different. This stage here, this cannot be 0. So 2x plus 1 cannot be 0, which means 2x equals negative 1, x equals negative 1/2. X cannot be negative 1/2, or it would cause the denominator to be 0. So for our domain on this one, we'll have to say domain negative infinity up to negative 1/2, skip, negative 1/2 up to 0, skip, and 0 on to positive infinity. So you have to check all stages of a problem, and especially watch out anytime you have these fractions. On this first one, it didn't really change the fraction, but on this one, because g went to the denominator, it did change our domain. The other tricky part with composing and decomposing functions is doing the reverse. So when we say to decompose, it's like looking at this, our final answer, and saying, what two original equations could I have put together to get this? What could have given me this? Or looking at something like 19, you see 2 over x, plus 1. What are the two original equations that could have gotten me there? There's usually more than one answer, sometimes several. And what you want to do is you want to look for the main overall patterns. So this is where knowing your parent functions is especially helpful. So knowing things like your x squared function, actually I'm just going to put these on the side really quick so we can see them. Knowing things like your x squared, your x cubed, your 1 over x, your absolute value, your square root of x. Those are the only ones I can think of right now. But there's lots of patterns that you see. These basic things, that's what you want to look for. So as I'm looking at the f of x here, I want to say what's the main overall shape, or perhaps what's the outermost function that I see happening. This is really faint, but there is a parentheses with something to the fifth. So one way you could say this is, if I want to have two composite functions here, let's say I want a g of x and an h of x. Again, remember you can name a function anything you want. The main overall picture that I see is I see something raised to a fifth power. Inside that something raised to a fifth power, I see a 2x plus 4. So perhaps if I did a g of h of x here, the way I've written my functions, I should get that f of x up top if I put the h into the g. So up here, can't just leave it blank. We do want an x, and that's a little weird for us, but you do want to put an x inside of there to say that's the function. This is what I put into that function. It got me the f of x. So you could say g of h of x, or you could also say g of h that way. That's one way that you could decompose this function. This one over here on the right, again, what's the overall pattern we see? I see something in a denominator. So I'm going to say I see 1 over something. That's going to be my first pattern. What did I stick into the denominator? I stuck x squared minus 2 in. So if I was to have an outer pattern of g, and into that pattern I stuck the f, I should get that h of x up top. I want a holding place here, so I'm going to say that's my x, and again, this could be g of f of x. These two together would give me h of x. These are definitely trickier. They take some practice.